This is eHobbyist blog, a log of electronics hobbyist activities aimed at city dwellers, retirees, students, and other not-so-nefarious characters who have limited space, limited money, and limited time. My name is Neil. Welcome. During this video, we will start work on the prototyping system's first function, enclosure. What I have here is a box. And I have to admit that this box has some dangerous dents in here. I hope nothing's wrong. Anyhow, I have to admit that this box was indeed opened before. I kind of cheated, so I know what's in here. But then again, so do you, if you have seen my previous videos. This box is actually the first sub-function box of the functional components diagram. So this box is really the first box. See if I can open this up before I cut my hand off. I don't know, if my money, if I were a betting person, I'd bet on hand off before box opening. I don't know. Okay, good. Now let me see what's inside here. What's in here is... Get it open. You can do it. What's in here is... Good. Another box, which has not been opened. Okay. And I've got some packing material I've got to take care of. I don't know why they need to use packing material made out of plastic, over-engineered, inflatable packing material, which I need to bust. Poke it with a knife and see if I can avoid my fingers. Okay, I mean, come on, use some reusable resources, some green stuff. How about some paper? Wrapping paper would do. No. Get rid of this. Okay. And now get rid of the shiny stuff. Some more packing. Okay, fine, yeah, right. I'm going to open this, come hell or high water. You're not going to stop me here. Oh, no, no, no. Yeah, come on. Okay. Let's throw this, some more packing stuff out of here. All right. Now, I would like to keep this box intact, the box within a box, so that I can use it to store the enclosure, which looks suspiciously like an audio console. Okay, let's see if I can pull it out here. Let me get it out. I know we can. All right. Now we got to take off some more packing stuff. Now this I can agree with. I mean, you need to protect the panel from being gouged prior to delivery. I'm virtually certain to scratch, gouge, and scrape this thing before I'm done. So I'm already planning on coating this thing with some more black paint. Now look how simple this stuff is. This is made out of 12 gauge aluminum, but the bottom component, which I'm looking at right now, it's just two bends. And it's simple, it's nice, it's straightforward. The only thing that's not simple about it is cutting the grooves out. If I did not find this on the web, I was going to build my own, and this is doable. I have a handbrake and I can make these bends. Making the bends for the top might be a little difficult. I might have to get a longer brake. And here we have the top piece. And notice the vents in here are on the top of the top panel, and we're front on the bottom panel. And the idea is to get convective airflow going. And where air comes into the bottom, hot air rises and flows out the top. And I'm hoping that that will be sufficient to get rid of the heat generated inside the prototyping system once I stuff this thing full of heat generating junk. Now, by my calculation, I'm going to have something in something between 40 and 60 watts of stuff. This is enormously interesting, equally astonishing. Yeah, but I'm going to have to get rid of a great deal of heat. And now, I've inspected this thing. There are no major defects, and what I'm going to do now is check the measurements. I mean, just because the invoice says that it's supposed to be this or that measurement, 20 inches and change, and what do I got? Well, I want to make sure that I know exactly what the measurements are. And it's my measurements that count, not theirs. I would not return it if the measurements were incorrect. I like the look of the console, but when I go to do the layout, I have to do the layout based on reality and not fictional data. Okay. And I notice that I'm continuing to maintain a log notebook. The idea of doing these videos was not to have to do that, and now I wind up doing it twice. Okay. And eventually I'll be making layout sheets from these measurements. When I first encountered the Hammond 1456 cabinet, I went to the Hammond site and didn't find it there. So instead I did a Google search, wound up with numerous hits, one of them on DigiKey. And on the DigiKey entry, I was able to find documentation for the cabinet from Hammond. Now that I have the diagram from the manufacturer Hammond and a set of my own measurements to confirm it, I'm in a position to create panel diagrams. We start with, and here's a diagram of the enclosure from Hammond, the manufacturer. And if you can imagine both top and bottom components kind of spread out flat and viewed from the outside, we get a panel diagram. The first panel diagram is the top component, and you're looking at it perpendicularly from the outside without taking into account things like bend radii and thickness of the metal, but just what I would see and drawn as precisely as I can possibly draw it. And then we have the bottom side of the enclosure, again viewed on from the outside and drawn as accurately as I can possibly draw it. What the panel diagrams are going to be used for is to draw the design first, draw the locations of holes and cutouts, then they're going to be printed out on a 1-to-1 scale, taped to the enclosure and used as a guide for center punches and X-Acto knives or scribing tools to punch the center of holes to be drilled and to make scratches in the enclosure surface to indicate what needs to be sawed out. Now, starting some design, I'm working from the top component panel diagram, the outside view, and I know because I have functional diagrams to what the component functions are, and now I can start positioning these components. We have inputs, which I would position from the left edge, outputs that I would position from the right edge going towards the center, and the breadboarding components themselves. Starting with the outputs, the first component we need is a power monitor, and I would position it roughly there, followed by an oscilloscope, which would be right there, And finally, I've got digital output monitors, which I would put there. In terms of the input side, I need to adjust power, put power on, and adjust the voltages, upper left. Working from the left side towards the center, I would put a function generator there. And now, from the center, I'm going to position binding posts initially, and then below that, power strips, and finally the breadboard itself. Now, probably below the breadboard, I'm going to position logic switches, because I'd like to have the switches on the bottom. Maybe they should belong on the left, I don't know. And then uncommitted components like BNC connectors and RCA connectors. I still have some stuff that I'm not quite sure where to put, but we'll continue the design as it proceeds, and I don't need to make these design decisions immediately. So far, we've started work on the first prototyping sub-function, enclosure. We unpacked the physical enclosure, examining it for defects, noted provision for convective airflow, and measured the enclosure to confirm manufacturer's specifications. We also created panel diagrams for both top and bottom panels and started design of the top panel. In the next video, we'll start work on the second sub-function, breadboard. If you like this video and the idea of the channel, click on the YouTube thumbs up icon. If you want to be notified as to when the next video is available, click on the YouTube subscribe button. If you want to suggest future directions or topics, make corrections to published videos, or voice your opinion on related matters, then leave a YouTube comment. It's not all that difficult, and I promise to read it. If you want to see supplementary material that cannot be easily presented in video form, such as high-res graphics, vector graphics, files in different formats, lists of references, go to the corresponding website. Until the next time, good day.